Hello everyone. In this video we are going to discuss the numerical from your unit number 1, that is vector analysis, and this numerical is basically related with the scalar triple product. This is what we are going to say that to be the scalar triple product and vector projections. So this is what we are going to say the scalar triple product and the component of vector P along vector Q. So that is basically divided into two components. One component that we will have that to be the scalar component, and another component that we will have is the vector component. So we are going to see that one. So before we start our numerical, I would like to ask you if you have any queries, you can write me a mail at this my email ID. So I will try to get you as soon as possible. Now we will begin with our numerical. Now within this numerical we are given with the three vectors, that is vector P, vector Q and vector R, that we have written over here. Now if you carefully observe for your three given vectors, so you will find that these two vectors are given with x, y and z component, x, y and z component. Over here we have the missing component, that is y component. So we can feel that with respect to, or you can say we can add up with that to be the 0 ay cap. So this will be your missing part, which is nothing but 0 ay cap and minus az cap. Now we will move on to our numerical. So what is asked to us? So very firstly we have to find out what is the scalar triple product. See, if it is not given within the numerical that uh, vector p dot vector q cross vector r, and if they have asked directly over here, find out the scalar triple product. So don't get confused. So these are the one and the same thing. Chances are high that you may not be habitual to these words. So what is scalar triple product? What is vector triple product? So scalar triple product is nothing but what? Your given vector P having the dot product with respect to one cross product with vector Q and vector R. So here in this case, this is said to be the scalar triple product. Okay, now we will find out that scalar triple product. So from the property of the scalar triple product, we have this that we are going to write very firstly what is the magnitudes along your vector P. So what are the magnitudes along your vector P? So that we have to be this 2, then this 0, and then this minus 1 over here. Now what are the magnitudes related with your vector Q? Magnitudes along vector Q are what? 2 minus 1 and plus 2. So that to be what? 2 minus 1 and this plus 2. And magnitude along vector R is equals to what? So we have that to be 2 minus 3 and 1. So magnitudes are what? 2 minus 3 and 1. So we have to simplify this determinant in order to get your scalar triple product. Okay, fine. So we have the property of the scalar triple product that very firstly we are going to write this 2 as it is. Now we have this minus 1 into this plus 1. So result will be what? Minus 1 minus of this minus 3 into 2. So that will be what? Minus 3 into 2 will be minus 6 plus this 0. As we already know that 0 multiplied by anything is 0, but still we are going to write what is the value over there. Okay, we are going to rub it right. Now this 0, so what will be that product over here? So that will be this 2 into 2, so that will be 4. Then this 2 into this 1, so that will be minus of 2. And then next is we have this minus 1. So we are going to write that minus 1 over there. And again, we are going to rub it out. So this is minus 1 over here, and this is 3. Okay, fine. Now this minus 1. Now product will be what now? 2 into this minus 3. So that will be minus. Okay, wait a minute. Wait a minute. Wait a minute. See, my handwriting is not as good as yours, so you just have to adjust with that. Huh? So this minus 1 is as it is. Now this 2 into minus 3. So that will be what now? Minus 6. And this, sorry, what is happening? Sorry, this 2 into this minus 3. So answer is minus 6. Then minus of this minus 2. Okay, fine. So we just have to simplify that one to get the answer. So answer is what? This 2 into minus 1 minus of minus 6. So that will be what now? Plus 6 minus 1. So that will be 5. That will be 5. Then anything multiplied by 0 is 0. And then this minus 6 and this minus 2. So that will be plus 2 minus 6 plus 2 will be minus 4. And this minus 4 into this minus 1. So that will be what now? Plus 4. So answer is what? We have the scalar triple product, or you can say the vector P dot vector Q cross vector R. So scalar triple product, and this is nothing but one and the same thing. So we have that answer to be 14. So this is the very first part of our numerical that we have found. What is the scalar triple product in between these three given vectors? Okay, fine. Now we will move on to the second part of the numerical, where we are going to find out the scalar projection as well as vector projections, or you can say the scalar component as well as the vector component of the vector P along vector Q. See, we are already have seen that the component of vector P along vector Q is classified into two components, or into two parts. Very firstly, we are going to find out what is the scalar projection or scalar component, and in the secondly, we are going to find what is the vector projection or vector component of vector P along vector Q. So very firstly, we are going to find out what is the scalar component of vector P along vector Q. If you find these videos to be lengthy, so I would suggest that you just watch it onto the higher speed, so that uh, you will cover up that speed. Okay, so what is the scalar component of vector P along vector Q? So we have that to be the very first given vector, as it is having the dot product with respect to the unit vector of your second vector. So here in this case, we have the very first vector to be your vector P. So that is as it is, and we have the second vector, that is vector Q. So we have to have the dot product with respect to the unit vector of your given second vector. So here in this case, your second vector is what? Vector Q. So we are going to find out the scalar projection of that vector P onto the vector Q now. So that will be what now? So that will be your given vector P as it is, and unit vector of your second vector, that is vector Q. So unit vector of vector Q is what? Your given vector Q as it is divided by magnitude of the vector Q. Okay, so we have the value for that vector P, and what is that vector P? So vector P is, we have this, that is 2ax cap plus 0ay cap. You can refer previous slide of the same numerical. 0ay cap minus az cap, and you can take the timely screenshots. Okay, fine. Now we have the vector q. So what is that vector q? So that is to be 2ax cap minus ay cap plus 2 az cap divided by magnitude of your vector q. So what is the magnitude? So that will be this 2 square plus minus 1 over here. Magnitude is minus 1 over here, so that is minus 1 square, and this is again 2 square over there. So we have this as your unit vector along q. Now you just take the dot product in between these two vectors, so that will be what? This 2 into 2, so that will be 4. This 0 into minus 1, so that will be you can say that to be 0 plus 0, and minus 1 into this 2, so that will be what now? Minus of 2 divided by. So if you simplify the square root, so what value you will have? 2 square is 4, this 2 square is 4, 4 plus 4 is 8, and minus 1 square is what? 1. So 4 plus 4, that is 8 plus 1, so that will be square root of 9, and square root of 9 is what? That to be 3. So from this we have the value for your scalar component or scalar projection of vector p along vector q, and that value is equals to what? That is equals to 2 by 3. So this is your final answer. Now next, within the next part we are going to find out the vector component of vector p along vector q. Now this vector component of vector p along vector q will be what? It will be the scalar projection that we have found already. Scalar projection of vector p on your vector q having the dot product with the unit vector of your second vector, that is vector aq over here. So this is what is we are going to say that is to be the vector component. So we have the scalar projection value from the previous slide, you can refer that one, that is to be equals to 2 by 3, and then we have to multiply it by using the unit vector of your vector q. So what is the unit vector for your vector q? So that will be your given vector q as it is divided by its magnitude of that vector q. Okay, fine. Now we are going to write the unit vector for your vector q. So this 2 by 3 is as it is. Now what is q? We have the q to be, you can see over here. Q is given to be what? We have vector q is equals to 2ax cap minus ay cap plus 2 az cap divided by its magnitude. So what is the magnitude? We have this to be the 2 square plus this minus 1 square, magnitude of that ay plus magnitude of this az. So that is to be 2 square. Okay, fine. Now this 2 by 3 is as it is, and this to ax cap, for now we will keep it as it is, to ax cap minus ay cap plus 2 az cap. What is the value for the square root? So it comes out to be what? 2 square and 2 square, that is 4, 4 plus 4 plus 8, and this minus 1 square, so that is 1. So 8 plus 1 is again square root of 9, and square root of 9 is equals to what? 3. Now you can simplify that one to get your answer. Either way you can divide this 2 by 9 and then multiply it by using this 2x cap minus ay cap plus 2 az cap. So you will find this answer to be equals to this, that it will be equals to 0.4444 ax cap minus this minus sign. So this is sort of cross check for your answer. So that it will be what? 0.2222 ay cap, and this 2 divided by, sorry, this 2 into 2 4 divided by 9, so that comes out to be again 0.4444 az cap. So vector component of vector p along vector q, or you can say the vector projection of vector p onto your vector q, is this one. So from the basic definition of that vectors, that we have the magnitudes along with its directions. So that gives you what? That gives you the vector component of vector p along vector q. Okay, so you can hit the like button to appreciate my efforts, and if you have any query, so you can drop me a mail. Okay, thank you.